Forget dark matter, it's dark energy that's keeping you up at night. Explore the strange and fascinating world of this mysterious force. Some 13.8 billion years ago, the universe began with a rapid expansion we call the Big Bang. After this initial expansion, which lasted a fraction of a second, gravity started to slow the universe down. But the cosmos wouldn't stay this way. 9 billion years after the universe began, its expansion started to speed up, driven by an unknown force that scientists call dark energy. We don't know whether it exists. It's making the universe expand at an accelerating rate, and approximately 68.3 to 70% of the universe is dark energy. Dark energy wasn't discovered until the late 1990s, but its origin in scientific studies stretches back to 1912, when American astronomer Henrietta Swan Leavitt made an important discovery about the class of stars whose brightness fluctuates with a regularity that depends on the star's brightness. Around this same time in history, astronomer Vesto Slipher observed spiral galaxies using his telescope spectrograph, a device that splits light into the colors that make it up, much like the way a prism splits light into a rainbow. He used the spectrograph, a relatively recent invention then, to see the different wavelengths of light coming from the galaxies. Redshift is a term used when astronomical objects are moving away from us, and the light coming from those objects stretches out. Light behaves like a wave, and red light has the longest wavelength. So, the light from objects moving away from us has a longer wavelength, stretching to the red end of the electromagnetic. The scientists confirmed in 1929 that the universe is expanding fast, but scientists previously thought that the universe's expansion would likely be slowed down by gravity over time, an expectation backed by Einstein's theory of general relativity. But in 1998, everything changed when two different teams of astronomers observed far off. After a few years, the researchers find the distance of the supernova by using its brightness. They found that the supernovae were not as close as expected, meaning they had traveled farther away from us, faster than anticipated. This makes it clear to scientists that the universe is expanding faster over time. While other possible explanations for these observations have been explored, astronomers studying even more distant supernova to gather evidence and build support for the idea that the universe is expanding faster over time, a phenomenon now called cosmic acceleration. Now there is a question that what exactly dark energy is. Right now, dark energy is just the name that astronomers gave to the mysterious something that is causing the universe to expand at an accelerated rate. Dark energy has been described by some as having the effect of a negative pressure that is pushing space outward. However, we don't know if dark energy has the effect of any type of force at all. There are many ideas floating around about what dark energy could possibly be. Here are 4 leading explanations for dark energy. Keep in mind that it's possible it's something else entirely. Some scientists think that dark energy is a fundamental, ever-present background energy in space known as vacuum energy, which could be equal to the cosmological constant. Space is never exactly empty. According to quantum field theory, there are virtual particles or pairs of particles and antiparticles. It's thought that these virtual particles cancel each other out almost as soon as they crop up in the universe, and that this act of popping in and out of existence could be made possible by vacuum energy that fills the cosmos and pushes space outward. Some scientists think that dark energy could be a type of energy fluid or field that fills space, behaves in an opposite way to normal matter, and can vary in its amount and distribution throughout both time and space. This hypothesized version of dark energy has been nicknamed Quintessence. Some scientists think that dark energy could be a sort of defect in the fabric of the universe itself. Defects like cosmic strings, which are hypothetical one-dimensional wrinkles, thought to have formed in the early universe. Some scientists think that dark energy isn't something physical that we can discover. Rather, they think there could be an issue with general relativity and Einstein's theory of gravity and how it works on the scale of the observable universe. Within this explanation, scientists think that it's possible to modify our understanding of gravity in a way that explains observations of the universe made without the need for dark energy. Dark energy is one of the great mysteries of the universe. For decades, scientists have theorized about our expanding universe. Now, for the first time ever, we have tools powerful enough to put these theories to the test and really investigate the big question: what is dark energy? NASA plays a critical role with ESA in Mission Euclid, which is launched in 2023, which will make a 3D map of the universe to see how matter has been pulled apart by dark energy over time. This map will include observations of billions of galaxies found up to 10 billion light-years from Earth. NASA's Nancy Grace Telescope, set to launch by May 2027, is designed to investigate dark energy, among many other science topics, and will also create a 3D dark matter map. This will allow scientists to map how matter is structured and spread across the universe, and explore how dark energy behaves and has changed over time. The combined efforts of Euclid and Roman will usher in a new golden age of cosmology, in which scientists will collect more detailed information than ever about the great mysteries of dark energy. NASA's James Webb Space Telescope, launched in 2021, is the world's most powerful and largest space telescope. It aims to make contributions to several areas of research and will contribute to studies of dark energy. The NASA New Spectrophotometer for the History of the Universe, scheduled to launch no later than April 2025, aims to investigate the origins of the universe. It will survey the entire sky in near-infrared light, including over 450 million galaxies, and could help to further our understanding of dark energy. Thanks for watching the video. Also subscribe the channel.